Hi guys, and welcome back to another lesson in Algebra 1. This is Unit 4, Lesson 9. We are going to be dealing with real-world slope-intercept equations. We do have our formula here, our equation here, slope-intercept, y equals mx plus b. We have our slope equation here. And in this lesson, we need to make sure that we know which one is the independent and which is the dependent. And then you're going to decide what slope and y-intercept mean in a real world context. So we're not just talking numbers, we want to know what it means. So in this particular lesson, we are going to identify the slope. So whatever the situation is, let's figure out what that slope is. Remember, slope is also known as rate of change. And so frequently it literally says that phrase in the problem. It'll be like, what is the rate of change in, blah, blah. It's asking slope. That's what that means. We're going to pay attention to whether this is an increasing situation, and increasing is going to mean it's got a positive slope, or if it is a decreasing situation, and in that case, the slope would be negative. We're going to pay attention to the independent. And remember, the independent variable goes on the x-axis. Okay, the independent and dependent variables. And the dependent is going to go on the y-axis. Okay, this is an important skill also to have for science. Science is all about setting up things that we can test and we can measure. And when it's graphed, it's going to have an independent and dependent. So you want to make sure that you understand that because it will help you in science as well. All right, so the next thing that we're going to look at is we're going to identify the y-intercept. And when we are looking at a particular real life problem, this is often going to be the starting value. So often, if we're talking about money, maybe it's the starting bank balance. It could be, it could be, I don't know, how many books you already have, and maybe you're buying more books. It's going to be something about a starting value. Or your y-intercept can be a one-time fee. So, for example, what if we had a problem where, you go to the store and you want to buy a gaming system in 3 games? Okay, well, you're only going to buy one gaming system. Okay, and then you might buy, you could buy 15 games, right? You could buy lots and lots of games for it, but you're only going to buy one gaming system. So that would be an example of a one-time fee. And then what you're going to do is you're going to write the equation in slope-intercept form. Remember, that's going to be your y equals mx plus b. And then they may ask you to make a prediction. Okay, so when I'm saying make a prediction, it may be that you need to calculate a new output. So, you could say, if we go back to the starting bank balance and maybe we're saving money, you could say, Bob has $10 in their bank account and they save $2 a week. How much money would they have after 10 weeks? Well, that is an example of calculating a new output, and it's going to be based on the equation that you write. So there we go. Let's look at this example 1. And if I am going too fast, just pause it because, of course, I'm recording this ahead of time. So it's very easy to just get on a roll. And so if I'm going too fast, just give it a pause so you can catch up. Alrighty, let's go read this problem. Let's see what's going on. So we got a reservoir currently has a water level of 820 feet. it decreases at an average rate of 1.6 feet per day during a dry season. So let's stop and kind of think about what are each of these numbers? What are they telling me? This here, this 820, this sounds like a starting value. Okay. And a starting value, we just said up here, my starting value is going to be a y-intercept. So if we are starting at 820 feet, that's a real good example of my y-intercept. Now let's look at this other part. It's decreasing. So this means it's going to have a negative slope. It's going down, every so often. Average rate, this is just another term for slope. Okay, so it's saying it has an average rate of 1.6 feet per day. It's saying it has a slope of 1.6 feet per day. And so my slope equals 1.6 feet per day, but remember, it is a negative because it is decreasing. So I'm going to go back and I'm going to add that negative right there to my slope. Alrighty, so we've identified our slope. We've identified our starting value, which is our y-intercept. We now can write a function. Okay, so it's telling us to write a function that can be used to find the water level after D days. Let me go ahead and just define my variables. Okay, defining my variables, yes, it is defined in the problem, but this is giving me a chance to get my brain organized and make sure that I understand each component. Okay, so this is called a let statement. It said WD, so this is in my function notation, it's going to be water level. Okay, and we can even see the water level is going to be in feet. And then we can see that D is days. Okay. Now, when we go to write our equation, let's think about it writing it slope-intercept form, which is y equals mx plus b. But let's also remember our fancy style function notation. So this y equals mx plus b, if we write it in function style, we can just write WD in place of that y, m, and then I'm going to just go ahead and put d here for my x for, in its place. And then there we go. Okay, so that looks a little confusing, but all I did is I just replaced different components of this to use what it told us in the problem. Okay, so I'm going to go plug this in. So my starting value is this B. Well, we said that was, 820 feet. So I'm going to go write plus 820. Okay. I'm going to write the WD, and I'm going to write D. The thing that I need to fill in is going to be this M. That is my slope. Remember, slope is abbreviated M, and it was this negative 1.6. So that's what I'm going to write in that spot is negative 1.6. And so now we have this written in function notation style. Okay. We could have technically also written it as y equals negative 1.6x plus 180. Okay, the function notation style is what you see up here. The WD equals negative 1.6d plus 820. 820. Why did I write 180? Let me go fix that. Okay, so, just to kind of give you this equivalent, that's what it looks like in equation style, and that's what it looks like in function style. All right, it's asking us to make a prediction. Okay, when you see this, it says, what will be the water level after 15 days? It's asking you to make a prediction. And it's asking you to make that prediction based on your equation. So we're going to make a prediction. Okay, it told us 15 days. So remember what 15 days is? That's my D value. So we got D equals 15 days. Okay, we can take that and we can plug it into our function. So we wrote this function here. So I'm going to write this down. I've got WD equals negative 1.6 D plus 820. This D, I am simply going to replace with 15, okay? Because that's what they gave us. So they're asking, what is the water level after 15 days? So we could do negative 1.6 times 15 plus what it started at. So every day it's draining a little bit more. Well, what's going to be its depth? What's going to be the water depth after 15 days? Let me grab my calculator and we can calculate this real fast. Okay, so I've got my Desmos calculator, super handy, awesome calculator. Let's go ahead and we'll just clear it all. I'm going to go ahead and type in my negative 1.6 times 15 plus 820, my starting height or depth of water. And so after 15 days, I see that I've got 796 feet left. So let's see, that was 796 feet. That is how deep the water will be after 15 days. Okay, now we could have it find or make a prediction the other way. Like, what if it gave us this where it says the water level is 756 feet? You know, how many days would it take for that to happen? So let's go define this real fast. Okay, so my water level, I'm going to come back up here. Remember, I define the water level, the water depth as WD. So I've got WD equals 756 feet. I'm going to write my equation over again, my function. So the water depth equals negative 1.6 days plus 120 feet, because that's what it started at. Now, it gave us, when it said the depth, it gave us this, right? This is what 756 feet is the water depth. So I am going to take that and I'm going to put that 756 right here. So negative 1.6 D plus 820. We're going to subtract 820 from both sides. So that cancels. Let me go ahead and grab my Desmos calculator. Where did I put my Desmos calculator? There it is. Okay. It took a little vacation, went and hid. Okay, so I've got 756 minus 820. Okay, notice that it's a negative number. That just means it went down 64 feet from where it started. And we're going to, so we write that down. We got negative 64 equals negative 1.6 days. We're going to divide by negative 1.6. This cancels. We're going to get a value for days. So let me grab my calculator again, and we'll divide 64 by negative 1.6. So let's see, we're going to divide, we're going to take negative 64 and divide by negative 1.6. And that gives me 40. So in 40 days, the depth of this particular body water will reach the 756 feet. It'll take 40 days for it to happen. Okay. So this is a way that, somebody might model a particular condition and see what happens as time passes. And you can think about this like, if we're talking about a place flooding and how long is it going to take for the water to drain? Or, if you could think of it the other way. What if you're trying to fill a water pool? How many hours might it take to fill a pool of water, if you have a particular flow going into the pool? So let's look at this other situation. We've got an elevator and it's currently 18 feet below ground level and it's rising at a constant rate of 4 feet per second. Well, what does each thing here mean? Okay. So the elevator is 18 feet below level. I'm going to make myself a little diagram. So this is going to be my ground level. And this thing is going down here, right? So here is my elevator. It's at negative 18 feet. Okay. It's not because distance is negative. It just means that it's 18 feet below ground. It's a way of specifying that something's below ground, not because a distance can be negative, because a distance cannot be. But this is giving me a location and a way to compare something that's underground versus above ground. Okay, it is rising up at a constant rate. This is my slope. And it's going at 4 feet per second. So my slope is going to equal 4 feet per second. And that negative 18, the 18 feet underground, this is going to be my starting value, right? And my starting value, that sounds like a y-intercept to me. So it asks us to go ahead and to write a function that represents the height of the elevator after t seconds. Okay, well, let's go define all those variables. We're going to write a let statement. It's a way of just getting us to organize our brains and know what each thing means. Yes, it says height is, what height is in the problem, but I'm going to rewrite it again because I'm trying to get my brain all organized and wrapped around the situation so I understand what's going on. So my h of t is my height, and that's going to be measured in feet. And then t, that is going to be seconds, right? It's time measured in seconds. So we've got those two variables listed. When we write an equation, normally it's y equals mx plus b. But it's asking us to write it fancy style. So it's asking us to write a function. So remember, this y, we're just going to simply replace it with this h of t equals m. And then that x, I'm simply going to replace it with t because that's what it's using for time. It's just abbreviating it t plus b. Okay, so that is what it would look like with a function notation. Let's go add our values to that. So we have a starting height, right? We can go grab that starting height. My starting height is this negative 18 feet. Okay, so we can put negative 18 equals, oops, wait a minute, I made a mistake. Let me back up. We're not going to write that there. I don't know why on earth I wrote it that way. Sometimes brains just kind of do funny things. Okay, I'm going to write this again. And sorry, this is my y-intercept. I have absolutely no idea why I wrote it there. Okay, my slope, let me color code this again. So we got this, and my slope is this guy. So my slope is this 4. Whoops, let me go highlight that. That's my 4. That's my slope, right? So we can put 4 times time. Now that is my function. Alrighty? So let's scroll on down and see what the next thing is. So now that we have our function, we can make predictions. It says after 7 seconds, so it gives us this situation. After 7 seconds, how far below or above ground is the elevator? So where is it after 7 seconds? Well, let's go back and grab our variable for seconds. So this t, that is seconds. So I've got t equals 7 seconds. I'm going to grab my function. So I got h of t. So the height is based on time, right? That's what that's saying. Equals 4 seconds times time minus it started at 18 feet below ground. Okay. So I'm going to take this time. Let's see, let's grab this. I'm going to take this time and I'm going to plug it in here for t. So I get h of t equals 4 times 7 minus 18. What this is saying is that it's going to rise 4 feet every second for 7 seconds. And so that looks like it's going to be above ground to me. 4 times 7 is 28. So it rose 28 feet in that 7 seconds, but it started 18 feet below ground. Okay. So this means after it rises 28 feet and it started 18 feet below ground, it is now 10 feet above ground. Whoops. Okay. That's why we, even though a distance can't be negative, we gave it a negative in the sense that we were trying to show that it was below ground. And so that's why that was important, so that we can make sure that we knew the correct distance above ground once it finally went up. Alrighty, if the elevator is 22 feet above ground, how long has it been moving? Okay, so in this case, the 22 feet above ground, that is going to be, let me go grab a color here. We'll grab this. That's going to be my h of t is 22 feet. Okay. The reason I know that's that because that's my height based on some amount of time. It's asking me to find time. That's what it's looking for. I'm going to write my function over again. So we got h of t equals 4 times t minus 18. I'm going to take this 22, and I'm going to replace my h of t. So I've got 22 equals 4 times time minus 18. I'm going to add my 18, add my 18. This cancels. 22 plus 18 is going to give me 40 equals 4t. We divide by 4. We divide by 4. So we can tell that it has been moving for 10 seconds. Running out of room there. It's been moving for 10 seconds. Alrighty? Okay, so this would be an example of how we kind of bring all of these components in this unit together and apply it to a real world context, and constantly thinking about what are these numbers and what are they telling me and how can I use that information to make some sort of prediction. Until next time, guys, bye.